Hi, this video is about special right triangle formulas and how we got them. This is a pretty short video, and after you watch it, you can go ahead and watch the video just on special right triangles. And I think I have a missing E right there, or S, there we go. So let's get started. First off, by special right triangles, of course, we're talking about 30, 60, 90. That's what we call them. And what we really mean is 30 degree, 60 degree, 90 degree. And then the other type is 45, 45, 90. And they're special in that you can go ahead and find the other two sides of a triangle if you just know one side, where the Pythagorean theorem normally can only work if you have two of the three sides. So this is what makes them special. All right, let's get started. The first one we're going to look at is this, how we came up with the formulas for the 30, 60, 90 triangle. And that's, again, that's short for, it really means 30 degree, 60 degree, 90 degree. We just call it 30, 60, 90. So I want you to start by thinking about a triangle that's equilateral, which means all the sides are the same. And equilateral triangles are also known as equiangular because all three angles are the same. So I'm going to mark all three sides congruent to show that they match. And then as you can see, all of the angles are 60 degrees. I'm going to squeeze in my little degree marks. Okay, so far so good. Now what I want you to do is just imagine that we split this triangle right down the center, like right down here. Okay? And what we have is two triangles now. And we're just going to work with one of them. At the very top of the triangle, I've split this angle in half. I've got an angle bisector. And what that means is this angle now has two 30-degree angles. Oops, sorry, this triangle has two 30-degree angles. And what I want to do is just work with one of those. Okay, so I'm going to kind of circle this triangle here, which is half of it. And I'm going to redraw it over here. And we'll just talk about how this came to be. All right. Going back to the original triangle, whatever the length of one of the sides is, all the other two are the same length. So if I know one of them, and I'm just going to call it x because it can be any number, and if this one here on the left side is x, so is the bottom one, and so is the right one. All right. So keep that in mind for the one that I redrew over here. This length right here represents this side right here, and it is going to be x. Let me go ahead and change this up a little bit and call this side here y, and we'll just kind of erase this a little bit so you can kind of see it like that. If this side is y, the hypotenuse is double y, 2y. And the reason is down here where I split this angle, this big triangle into two triangles, I've cut the base into half. And what I have is two congruent line segments that make up the whole. And over here, this line, this base right here, or the half of the base of the original, is half of x. I'm just going to call it y. And whatever that value is, this side right here is twice that length. And I'm just going to call it 2y. Now our job is to find this side over here. Let me go ahead and mark the angles. This angle is 30 degrees. This is a right angle. And this angle over here is 60 degrees. Okay. Remember that the smallest angle is opposite the smallest side, and the largest angle is opposite the largest side. So if we want to order our sides based on the angles, I would know that my largest side is opposite my 90-degree angle. So this is going to be my largest. My smallest side is opposite my smallest angle. Well, this is my smallest angle because it's 30 degrees. So this is my smallest side. And then my medium size would be this leg over here on the left. Okay, I want to call it medium. I like to call these small, medium, and large. Now, let's find the length of the medium side. The Pythagorean theorem says that the sum of the squares of the two legs equals the square of the hypotenuse. So let's go ahead and write that out. We think of it as a squared plus b squared equals c squared, but in this case, it's going to be y squared plus, well, the one we don't know, let's just call that m for medium, okay? And that equals, well, instead of c squared, it's actually 2y. So I'm going to close that in parentheses and square it. And what I have now is y squared plus m squared equals 2y, the quantity 2y squared. Well, that's going to turn into 4y squared because I'm squaring the 2 and the y, right? So 2 squared is 4. So now I've got y squared plus m squared equals 4y squared. Let me kind of work up here a little bit. If I subtract y squared, or 1y squared from both sides, I now have m squared equals 3y squared. Okay? Again, that's because this is 1y squared and I subtracted 1y squared from the right and from the left. So now I want to find out what just the medium side is, and I'm going to take the square root of both sides to simplify that. The square root of m squared is m. Okay? The square root of 3y squared is the square root of 3 times the square root of y squared. And I can go ahead and take one more step and simplify y squared into just y. And what I have is a relationship between y, which is the measure of the smallest side, and the medium side. And you can see that it's basically the smallest side times the square root of 3. Let me go ahead and write that here. Oops. It's the square root of 3 times y. All right? So let me kind of clean that up a little bit. And, oh, that's not what I want. I'm going to go create another one. When you draw a 30, 60, 90 triangle, it's just real important to keep in mind that you want to have one leg that's clearly longer than the other, and that makes you see the small, medium, and large triangles a little better. Okay, so I'm going to have a right angle here, and then I'm going to have my smallest angle is going to be 30 degrees, my biggest angle is going to be 60, and again, just keep in mind that this is half of an imaginary 60, 60, 60 triangle. If I were to double this 30-degree angle, I'd have another 30 over here. This would be a big equilateral triangle. All right. So I know that whatever this value is here, that's my smallest leg. All I have to do is double it because it really represents half of the side of an equilateral triangle. So whatever it is, I double it to get the hypotenuse, and then I multiply by the square root of 3 to get the middle side. All right. Another way to think about it is if I know the hypotenuse, I cut it in half to get the smallest side. Okay, so we'll work more with that in the other video. What I want to do now is move on to the 45, 45, 90 triangle and just kind of show us where that came from. I'm going to go back. This is a picture of a 45, 45, 90 triangle. And a 45, 45, 90 triangle, since I have two angles that are the same, I have an isosceles triangle with two base angles that are congruent, and therefore the two legs are congruent. And in this case, I'm just going to go ahead and call one of the legs x. Now, if I know one leg length, I automatically know the other leg length because they're congruent. So I can call that one x. So let's use the Pythagorean Theorem to figure out the length of the hypotenuse. Okay. Now, I guess for now I'll just use h to represent that variable for that. Remember, it's a squared plus b squared equals c squared for the Pythagorean Theorem, with the c being the length of the hypotenuse. My a squared and my b squared represent the two legs. Well, they're the same. They're both x. So it's going to be x squared plus x squared equals, I'm going to call this my h, or my hypotenuse squared. I can combine these two like terms. X squared plus x squared is 2x squared. Okay, getting a little closer here. Well, I'm trying to find out the value of just h, not h squared. So I'm going to take the square root of h squared, and I have to, whatever I do to the right, I have to do to the left. So now I've got the square root of 2 times the square root of x squared equals the square root of h squared is h. Okay, I can do a little simplifying here because the square root of x squared is simply x. All right, and this is pretty neat. The hypotenuse is equal to one of the sides, the side lengths, times the square root of 2. Let me just cross that off. That way I can represent the hypotenuse in terms of the side. Okay, so it's x times the square root of 2. Or a lot of people write it as the square root of 2 and then an x. You gotta be careful so that it's very clear the x is not under the radical, so it's separated. What's really neat about both of these formulas is that a lot of people get confused about which radical to use, whether it's the square root of 2 or the square root of 3. Please note that for 45, 45, 90 triangle, there's only 2 different lengths. You basically have two sides that are the same length as each other, and then one hypotenuse that's longer. And that one uses the square root of 2, where if we go back to 30, 60, 90, you'll see that you have a small and a medium and a large side, small, medium, and large, 3 different lengths, and that formula uses the square root of 3. So I personally think that's pretty neat. It's right here where we can kind of see that better. This is my small, this is my large, my hypotenuse, and my medium, 3 different sizes, square root of 3. And that's the end of this video.